The most common mistake I see with students simplifying radicals comes in many, many different forms. But in this video, I'm just going to show it to you two different ways, because sometimes we'll show it, you fix it, you address it, and then it shows up again, and you still make the same mistake. So let's address kind of like the first form, and then we'll do the second form. OK, so the mistake is a lot of times students will say, oh, well, the square root of 16 plus 9, I know I can take the square root of 16, and that's going to be added into the square root of 9, because I can take the square root of that. And you say the square root of 16 is 4, plus the square root of 9 is going to be 3, so therefore that's going to equal 7. Unfortunately, ladies and gentlemen, the square root of 16 plus 9 does not equal the square root of 16 plus 9. And the way that you can think about that is because I can simplify 16 plus 9, right? I know that 16 plus 9 is going to be a 25. And I know what the square root of 25 is. That's simply just going to be 5. So don't do this. Now again, the confusion comes into because students remember the rules of radicals that if you have 9 times 16, so you have your radicand is a product, then yes, indeed, you can simplify that to the square root of 9 times the square root of 16, which in this case would be a 3 times 4, which is equal to 12. And again, the reason why that works is because 9 times 16 is going to be 144. 9 times 10 is 90. 9 plus 6 is 54. 90 plus 54 is 144. And you can see that's going to equal to 12. So the main thing to remember is do not distribute your radical when you have terms separated by addition or subtraction. It doesn't work that way. Now, we work on this, we fix it. Students are like, OK, I understand. I'll write it on my hand. I'm not going to make that mistake again. And then we start getting into variables. And guess what problem shows up again? Another term where we know we can take the square root of something. I can take the square root of x squared, and I take the square root of 4. So students totally forget about it because it's probably been like a couple chapters ago. And then they say, oh, well, that's simply just going to be the square root of x squared minus the square root of 4, which is simply a x minus a 2. And no, ladies and gentlemen, unfortunately, we cannot do that either, right? Because we already proved you cannot take the square root across addition or subtraction. So what can this simplify to? Well, unfortunately, there's not many different things that we can do with this. We can factor the x squared minus 4. That can be factored down into an x minus 2 times an x plus 2. That's the difference of two squares. But that's really about all that you can get in that case. You could rewrite your x squared minus 4, you could rewrite it as a rational power, but there's really nothing else we can simplify for. So depending on what you're trying to do with your problem, do not try to simplify by distributing your square root across addition or subtraction. That is the most common mistake that I see students make. And even though when they learn it, they get checked, they still make it again and again. So make sure this is written on your hand, embedded in your brain, and don't make that mistake.